So fetal circulation is a fairly interesting topic. Circulation in the unborn child is going to be different from circulation in you and me in a number of ways. And we want to understand those. At some point, if you go into nursing, you're going to do some rounds in labor and delivery. And understanding these facts about the circulation in the unborn child is going to make a difference. So let's do a little background knowledge. Anybody know how long it takes to develop a baby? Yeah, everybody says 9 months. More technically, 9 months and 3 weeks, or a total of 40 weeks is usually the measure. You go in to see your OBGYN, you're pregnant, says, when was your last period? And he starts calculating, well, you must have been fertile at this point, you could have conceived here, da-da-da-da. Total of 40 weeks. Now, what many people don't know is that there are actually two distinct phases or stages in this process of growing a baby. The first 12 weeks of that is the unborn child is called an embryo. After those 12 weeks, for the next 28 weeks, it's called a fetus. Okay, what's the difference? Well, the embryonic stage is the developmental stage. Okay, this is where the child is putting all of its body parts in place. Think at the beginning of this, conception provides a fertilized egg cell. Remember what you were doing yesterday? Remember what you were doing a week ago? Remember being a kid at a birthday party or something? Remember being a fertilized egg? No. Right? But once upon a time, all there was of you was a single cell and a genetic code. And now, here this is today. Here you are. But that cell had to become 2 cells, 4 cells, 8 cells. Through a process of division, there was a mass of cells. It turned itself into a ball. Part of the ball got thicker and began to grow a little individual inside the ball. Step by step by step, the human body was grown. At 12 weeks, you have something that looks just like a human being. Fingers, fingernails, toes, organs, brain, eyes, head, everything is there. It takes 12 weeks to get all the body parts in place. Heart's beating, everything is there. At about 12 weeks, that finishes up, and there still is a time that's required for what we might call maturation, where, yes, there is a stomach here, but it hasn't developed all the layers to the point that it could be a stomach yet. The lungs are technically there, but the cells and the structures have not matured to where they can handle oxygen. So this is sort of the growth and development, let's say, of the organs once everything is put into place. If something goes wrong at the embryonic stage, it's usually some sort of gross deformity. Because if you interrupt the development of, say, an arm or fingers or a hand or a foot, or something like that, then you're going to have something, as it grows beyond that original deformity in part of the process, you're going to have something that's very, very deformed. Problems that occur more in this fetal stage, this last 28 weeks, tend to be just relegated to just parts of the human body. Or maybe an arm won't grow as long. It'll still look like an arm, but maybe it won't grow as long as it should be. Something like that. Now, there's a challenge for the child, because the child is isolated from the world, right? We've talked about these maintenance systems as providing the cells of your human body with the raw materials from the world that are needed to maintain the life of the cells. But when the child is isolated in the womb of the mother, it does not have that availability, right? There's no air in here, is there? There's no little snorkel going to the outside world. There's no food in here. Nobody's going to set up a little McDonald's, inside there. So the resources that would normally be there and the places where the cardiovascular system would go to find those resources are not there. Okay? Now you know that the maintenance systems, these 4 systems we've been talking about, really we've talked about 1, we've mentioned the other 3. We're going to talk more about the other 3 later. But these maintenance systems are the ones that sustain the cellular life. Cardiovascular system develops very early in development. About the 4th week, you've got a twisted tube that's beginning to pulse and is getting ready to pump blood. When you think about this embryonic stage, right? The first trimester, the first 3 months, the body is developing. A woman is a good deal through that before she even knows she's pregnant. Right? She misses her period. She goes, oh, did I miss it, or is it late? Then once she's starting to think about it, she may be 3-4 weeks past when conception took place. Right? Then she really worries about it for a week. Then she goes get a tester. And you can be halfway through the embryonic stage before you even realize you're pregnant. If you've been doing risky things with your body like drugs or smoking or alcohol or whatever, that could have had an effect on this child, and the child is halfway through its developmental stages before you're even up to the fact that, whoa, I'm pregnant. There's a child growing inside of me. So these are important things to think about. If you're engaged in risky behavior, things that could cause a child to come along, right, you really want to take care of your human body. Because that child is going to be well along before you finally realize, oops. Yeah, Ava?
So how close are you, like, not us knowing they're not well?
If you were on birth control pills where something went wrong, maybe you didn't take them, so you were fertile, and then you're taking them. When you're taking birth control pills, do you go through a menstrual cycle? People taking birth control pills, do they go through a menstrual cycle? Yeah. Not really. It depends on the strength of your birth control pills. But typically, if you're right on the edge, you might have a tiny little menstrual cycle, but maybe not. So if you're pregnant, it's the same thing. If you were on birth control pills and missed some and then got pregnant and then kept taking them and thinking, oh, I'm taking my birth control pills so I don't have my menstrual cycle, that's the same thing when you're pregnant, you don't have a menstrual cycle. There's a solution to menstrual cycle, right? You won't have your period if you get pregnant. Okay? Let me keep going here because this is going to take... So, transportation is up and running early. And that really isn't our problem. The problem are the entrances and the exits, right? The entrances and the exits are blocked. For you and me, air comes through my respiratory system, right? Food comes through my digestive system. These are no good in the developing child, right? For one, they're undeveloped, right? They even haven't started, they're there, the stomach is there, the liver is there, the intestines are there, but they haven't matured to where they could do anything yet, for one, right? These are not functional yet. But I think even more important than that, these things don't have access to the raw materials. The lungs don't have any access to the air. The respiratory or the digestive system doesn't have access to food. These three systems are going to become more and more active as the child nears birth, but still you're locked into this womb and there are no resources. So, what does the fetus, what does this unborn child have that allows it to get oxygen and nutrients and all the rest? What is there? The what? The umbilical cord connected to the placenta, right? All the entrances and the exits for the unborn child are in one place, in a temporary organ called the placenta, right? After the child is born, do we have any need for the placenta? No, you can throw it out, or, like there are some animals that eat the placenta, right? And I've even heard of some human beings doing that. Fry it up and serve it up there, But it's just organic tissue, right? But for the time that it's there, it's critical, okay? The placenta is the marriage between the mom's body and the baby's body. Otherwise, the child is totally separate. In this picture, you see this very delicate placenta surrounding this fetus that's developing here. What's so amazing about the placenta is that it is the marriage of two human beings' tissues, right? Is this the mom? Is this mom? No. This is the baby. This is a different human being, right? It's got its own genetic code. Came from mom. What if I took somebody else's tissues and transplanted them into your body? Anywhere. What would happen? You would reject it. Your immune system would say, that's not me, and would begin to attack it. Why doesn't mom begin to attack the baby? Actually, the baby is isolated in a chamber, but why doesn't it attack the placenta? What? Not blood-brain barrier, because that's a separate location. No, because it's still, even if you have, your brother and sister have some of your chromosomes. We can't put your brother or sister's tissues in your human body. We can't even put your parents' tissues in your human body. What? They do not share the same blood supply. Child has its blood supply, mom has her blood supply. What we found out was that in the placenta, mom's body naturally suppresses that part of her immune system that would attack something that isn't her. It's a natural product. It breaks down the signals or the triggers for the immune system so that it will not attack that. And in fact, this is where we have learned how to transplant something into somebody's human body. We do heart transplants today because we finally understood how the placenta did it. And we're just doing what the placenta does naturally in the body of a person. We're supplying a drug that suppresses that one part of your immune system that would attack another foreign tissue. We're able to leave your body defenses intact. We're just suppressing that one part which is naturally done in the placenta. So we've learned something from nature here as to how to do organ transplants in people. Okay? So rejection is suppressed here.
I have a question on this. I'm RH negative when I was pregnant.
Mm-hmm.
I get shocked.
Right. Right. And that's a totally different thing than what we're talking about here. But it is part of your immune system. And we're going to have to leave that for your physiology class. If I explained that right now, we would never get through this right here. But RH negative is an interesting topic. You'll get that when you study blood and physiology.
I was just going to ask what happens to the
Right. Well, that's connected to the placenta, and after the mom delivers the child, then she delivers the placenta after that. Okay, her uterus, without the child in there, gets smaller and smaller, but then it begins to push the uterus right out, and the rest of the umbilical cord and the uterus then come out of her womb. The umbilical cord connects the child to the placenta. Okay, I'll have a picture of that. We'll get to that in a second. Just before we do, though, think, now what is the placenta to the child then? In the developing child, the placenta functions as the respiratory system, the digestive system, and the urinary system. This becomes, like those three systems are, the entrances and the exits from the child's body. So all the things that the child needs are out in the placenta. Because of that, we've got to have a different circulating pattern. Yes, we're still going to circulate blood through the lungs, but the blood isn't going to come back oxygenated. Blood is going to circulate through the unborn child's digestive system, but no nutrients are going to be there, right? It's all in the placenta. Okay? Now, kind of like this comment, fetal circulation and maternal circulation are separate. The child has its own blood, mom has her own blood. They can even have different blood types. The blood does not mix. Mom's blood doesn't flow through the baby, nourishing it. The placenta is the place where mom's blood and baby's blood become intimate. Membranes separate them. During her menstrual cycle, the woman developed a thick lining in her uterus called the endometrium. And it became thick and rich with blood, expecting a fertilized egg cell to come along. If the fertilized egg cell does not come along, then as the menstrual cycle wanes, then this lining then is lost, and that is the menses. If the fertilized egg cell comes along, it burrows down in this lining and begins to grow its own blood vessels down in the rich, bloody, spongy endometrium. And that is what makes the placenta, the marriage between the baby's tissues and the mom's tissues, where the blood vessels, the capillaries, become intimate with one another. And literally then, anything in the baby's blood can pass into the mom's blood, and anything that's circulating in the mom's blood can cross through. That is the plasma, okay? The blood cells are not going to cross. Large things aren't. But all of those nutrients, oxygen, everything dissolved in the fluid is going to cross. If mom's drinking alcohol, alcohol will cross into the baby's body. If mom's smoking, the chemicals that are absorbed into her bloodstream will circulate into the baby's body. If mom's taking Tylenol, the baby's taking Tylenol. Right? We try to encourage a pregnant woman not to add anything different to her human body if she possibly can. Even over-the-counter drugs are not the best idea. Okay? So things are separate here. The bloods do not mix. Okay? Things exchange across the placenta. So everything that your child needs, respiratory, digestive, urinary, oxygen, nutrients, they're entering here. The waste products are going out. When mom breathes oxygen into her bloodstream, that oxygen circulates. When it reaches the placenta, that very oxygen she breathed is passing into the baby's body. The food that she's eating, those nutrients are building the child's body. All the little tissues here are being built from the food that mom was eating. Part of her hamburger is in there. Okay? The hamburger gets simplified into simple little molecules, but those molecules are built back into a child. When the child produces waste products from its natural metabolism, those waste products cross into mom's blood, and when that blood passes through her kidneys, it's filtered out. When she pees in the toilet, some of the urine going in the toilet was the child's urine, which passed into her blood. She's peeing for two. Okay? So her body becomes the entrance and exit by way of the placenta for everything that the child needs. Okay? Now you want to think about this blood coming back from the placenta for a moment. Okay? Think of it like this. In you and I, we get oxygen through our lungs, don't we? But we get food through our digestive system, right? The nutrients are here. We clean our blood in the urinary system here, don't we? In the child, all of those things are in one place. This is great blood, isn't it? This blood comes back from the placenta, oxygenated, nutrified, and cleansed all in one, doesn't it? This is high octane stuff, right? You've got really nutritious blood coming out of your digestive system, but the oxygen was given up to the digestive tissues. Waste products were absorbed from the digestive tissues. So that hepatic portal blood is only rich in one thing, right? The blood coming out of my lungs is only rich in one thing, oxygen. It gave up the nutrients to the lung tissues. It absorbed waste products from the lung tissues. So I have a general quality of blood. I have blood that has one quality here or there. This blood has got it all, doesn't it? This isn't tap water. This is Arrowhead Mountain spring water, right? This isn't the regular gasoline at the pump. This is the high octane stuff. This is great blood. Now, how does that blood get to the child? It comes through the umbilical cord, doesn't it? And so let's talk about the umbilical structures. Overall, there are going to be 5 structures that you need to know in fetal circulation. Okay? And we're going to deal with 2 of them right here. Let's look at the umbilical structures. This is going to be our placenta. Here's our umbilical cord. Here's the child. Now let's see what you might recognize here. You might not recognize the aorta in this picture. Can you see where the aorta is in this picture? Why might you not recognize it? Because it's not red, is it? Why isn't it red? By the time we're done here, you're going to understand why the blood running through the aorta is not oxygenated much, is it? Okay? But the blood that's going to reach the placenta is the blood coming down here. We dissected the umbilical arteries in the cat, didn't we? Didn't I show those to you? Right? And if you remember, if you came down the aorta, you divide into common iliacs, remember? External iliac, internal iliac, and the little umbilical arteries, there's 2 of them, come from the internal iliacs, and literally the blood pressure in the aorta and these arteries is pumping the blood out to the placenta. The child is pumping its blood to the placenta. Okay? Now, that blood becomes rich, that high octane stuff. Okay? So the poorer stuff is going out through arteries. It's kind of like the pulmonary circuit, isn't it? Where the arteries are carrying the low-level blood, right? And then there is a single umbilical vein, this big red one, bringing what? The high octane stuff, right? The rich stuff back into the child's body. So 2 umbilical arteries and a single umbilical vein. If this umbilical cord ever got blocked or pinched or squeezed or whatever, and you cut off circulation to the placenta, you could circulate blood here all you want, but you would never get the resources to sustain life. Okay, so make sure that you can identify 2 umbilical arteries and 1 umbilical vein, taking poor blood out to the placenta and bringing great blood back into the fetal body here. Now, circulation has to be different here, doesn't it? Because we're bringing blood back into the fetal body, the good stuff, through a fetal vein, right? Now, what's the problem with a vein? Most veins have low pressure and deoxygenated blood in them, right? If this vein is going to enter the venous system with all the other deoxygenated blood, how am I going to get this blood where it needs to go? This rich blood is entering the venous system. That's a problem. It's also entering here in the center of the body. Might be nice if I had that good blood connected right to the place that needs it most, but it's not. Okay? So the question is, how can I get this great blood to be routed from the placenta to the areas that need it the most? Well, yes, the entire body needs it the most. But if I was going to send it to just a limited number of places, if I was going to try to get the best blood to the most important place, where would I go? What's the most complex organ in your human body? Your brain, isn't it? Right? What organ is responsible for directing your personality and all of your actions, all of your thoughts, really who you are, right? As a physical person, you are in your brain, aren't you? Something goes wrong with your brain, you become a different person, right? So the question really is, how am I going to get the blood from the placenta to the brain as efficiently and effectively as I can, especially when I have to go through the venous system of the human body? Okay? How do I get the high octane stuff to the brain? And that's what much of the rest of this is going to explain. Okay? The brain needs this. It's so complex. It gets up and running very early. If I ask you what's the largest part of the child's body, it's the head, isn't it? Everybody knows that. The child, when it's developing, when it's at that embryonic stage, passing into the fetal stage, the head is half of the body. The child is half head and half body. By the time it's born, it's about 1/4 head and 3/4 body, right? And when you get to be an adult, your head, as a measurement of you, is only about 1/6 or 1/7 proportion of your whole body. But the head grows fast and well. The brain is growing fast and well because we have a mechanism to get great blood from here to where it's needed most. And if you keep that in mind, you'll be able to follow this pattern fairly well, I think. Okay. So, I guess this is just what I've just explained. When you think about this, the rest of the body, the heart is important, but it's not very, very complex. It's a bunch of cardiac muscle cells. Most of the body is simple compared to the brain. Okay? That's the point we're making here. Okay. So let's take it this